Electronic textiles bricks that enable electronic components such as batteries, lights, sensors, and microcontrollers to be embedded in them. They are not to be confused with smart textiles, which are fabrics that have been developed with new technologies that provide added value. Many smart clothing, wearable technology, and wearable computing projects involve the use of e-textiles. Electronic textiles are distinct from wearable computing because the emphasis is placed on the seamless integration of textiles with electronic elements like microcontrollers, sensors, and actuators. Furthermore, e-textiles need not be wearable. For instance, e-textiles are also found in interior design. The related field of fibertronics explores how electronic and computational functionality can be integrated into textile fibers. A new report from Scientifica Research examines the markets for textile-based wearable technologies, the companies producing them, and the enabling technologies. The report identifies three distinct generations of textile wearable technologies. First generation attaches sensor to apparel. This approach is currently taken by sportswear brands such as Adidas, Nike, and Under Armour. Second generation products embed the sensor in the garment, as demonstrated by current products from Samsung, Alphabet, Ralph Lauren, and Flex. In third generation wearables, the garment is the sensor. A growing number of companies are creating pressure, strain, and temperature sensors for this purpose. Future applications for e-textiles may be developed for sports and well-being products, and medical devices for patient monitoring. Technical textiles, fashion and entertainment will also be significant applications. The basic materials needed to construct e-textiles, conductive threads, and fabrics have been around for over 1,000 years. In particular, artisans have been wrapping fine metal foils, most often gold and silver, round fabric threads for centuries. Many of Queen Elizabeth I's gowns, for example, were embroidered with gold-wrapped threads. At the end of the 19th century, as people developed and grew accustomed to electric appliances, designers and engineers began to combine electricity with clothing and jewelry, developing a series of illuminated and motorized necklaces, hats, brooches and costumes. For example, in the late 1800s, a person could hire young women adorned in light-studded evening gowns from the Electric Girl Lighting Company to provide cocktail party entertainment. In 1968, Temporary Craft in New York City held a groundbreaking exhibition called Body Covering that focused on the relationship between technology and apparel. The show featured astronaut space suits along with clothing that could inflate and deflate, light up, and heat and cool itself. Particularly noteworthy in this collection was the work of Diana Du, a designer who created a line of electronic fashion, including electroluminescent party dresses and belts that could sound alarm sirens. In 1985, inventor Harry Wainwright created the first fully animated sweatshirt. The shirt consisted of fiber optics, leads, and a microprocessor to control individual frames of animation. The result was a full-color cartoon displayed on the surface of the shirt. In 1995, Wainwright went on to invent the first machine enabling fiber optics to be machined into fabrics, the process needed for manufacturing enough for mass markets, and, in 1997, hired a German machine designer, Herbert Selbach, from Selbach Machinery to produce the world's first CNC machine able to automatically implant fiber optics into any flexible material. Receiving the first of a dozen patents based on LED/optic displays in machinery in 1989, the first CNC machines went into production in 1998, beginning with the production of animated coats for Disney parks in 1998. The first ECG biophysical display jackets employing LED/optic displays were created by Wainwright and David Beekove, the CEO of X-Movier at the time, in 2005, using GSR sensors in a watch connected via Bluetooth to the embedded machine washable display in a denim jacket, and were demonstrated at the Smart Fabrics conference held in Washington, D.C. May 7, 2007. Additional smart fabric technologies were unveiled by Wainwright at two FlexTech flexible display conferences held in Phoenix, Arizona, showing infrared digital displays machine embedded into fabrics for IFF, identification of friend or foe, which were submitted to BAE Systems for evaluation in 2006 and won an honorable mention award from NASA in 2010 on their Tech Briefs, Design the Future contest. MIT personnel purchased several fully animated coats for their researchers to wear at their demonstrations in 1999 to bring attention to their wearable computer research. Wainwright was commissioned to speak at the Textile and Colorist Conference in Melbourne, Australia on June 5, 2012. where he was requested to demonstrate his fabric creations that change color using any smartphone, indicate colors on mobile phones without a digital display, and contain Wi-Fi security features that protect purses and personal items from theft. In the mid-1990s, a team of MIT researchers led by Steve Mann, Thad Starner, and Sandy Pentland began to develop what they termed wearable computers. These devices consisted of traditional computer hardware attached to and carried on the body,